In this lesson, we are going to talk about graphing an absolute value function. So let's start by looking at the parent function. Y equals the absolute value of x. So this picture that we're looking at is what we call the parent function. It means that our vertex is at 0 and it opens up with a slope of 1. So if you look, each of these lines goes up 1 over 1 in each direction, right? So this one obviously has a slope of -1, but I like to think of it as it has a slope of 1 going in both directions from your vertex. Okay? Now the parent function could also flip and you could have a slope of -1 going in both directions. So you just have to pay attention to your function. One of the notes that I want you to make, we do have a process written out for you on how to use a table. Okay, but I want you to write this down. The absolute value function is actually y equals a absolute value of x minus h plus k. And if you remember from our previous lesson, we get our vertex from the h and k. And now we are going to get our slope from a. Okay, and if that slope is positive, it's going to open up. We call that our orientation. Whether it opens up or if the slope is negative, it's going to open down. Okay, so that's your orientation. So every time you see a graph, I want you to think about what is your vertex from your h and k, what is your slope, that comes from a, and then what's the orientation? Is this going to open up or is this going to open down? So let's jump right in and try one. If we look here, let's find those three things. So first of all, our vertex. What is the vertex looking at this function? Remember that we start here and it kind of lies to you. You don't want to take, because the formula is x minus h, but the vertex is just h, we change whatever sign is here. So this is a negative, so our vertex will actually have a positive 7. And then the plus 2 stays the same. So that's our vertex. Our slope, we want to look in front of the absolute value bars, and in this case there's nothing there, so it's kind of like that invisible 1. So our slope is a positive 1, and because it's positive, that means it's going to open up. So let's go put that on the graph. I'm going to count over to 7, 2, and that would be about right here. And then in each direction, I'm going to go up 1 over 1, up 1 over 1. Oops, a little off. And as you can see, it creates that V shape that we're looking for. And so then I can just put my lines on there, connect your lines. There's 1. There's 2. There we go. So let's go look at the next one. Again, start by finding those 3 pieces of information. We're going to start with our vertex, which remember comes from that h and k. So I'm looking at this and this. Remember that we always change the sign. So if this says positive 3, we're actually going to use a negative 3. And then we just bring down that negative 6. So our vertex is negative 3, negative 6. Then we want to look for our slope. And that's, remember, in front of the absolute value bars. So that's going to be this guy right here. So this time our slope is 2. We don't get a lot of these at the Algebra 1 level where our slope is going to be more than 1, but it's nice to know just in case, because if you can do these, you can do almost any of them. And then because it's positive, will it open up or open down? It's going to open up. Positive always opens up. I like to think about it as kind of creates a smile. It's got a positive attitude. So let's go plot that. We're going to go plot our vertex at -3, -6. So that would be about here. And then our slope this time is 2. So we're going to go up 2 over 1 in both directions. So I'm just making my dots. It's helpful to me to make lots and lots of dots because then when I make my lines, I can use a ruler or a straight edge and it just makes it nicer and neater. And so then if I'm using that graph for anything, like to evaluate a function, it's just helpful. And that was way off. Okay, I think I've got my lines in place. So again, having the more dots you have, the more accurate your graph will be, which will be good if you're trying to find key features or if you're trying to evaluate the function, then you know for sure where it's crossing. Okay, let's try example 3. Why don't you start by finding the key pieces of information? So our vertex, remember, comes from inside the function. We had the +2 and the -5. Remember that the one inside kind of lies to you. It says it's positive, but it's really negative. And then outside we keep the sign. Good. And then our slope, remember that's outside in front of the bars. And here I just have a negative. And so remember we slipped that little 1 in there. So our slope is really a -1. And this time, because it's negative, we can say that our orientation is it opens down. So this one will look different than the other two that we've done. So I'm going to go, everything else is the same. We're going to go plot the vertex. I'm going to go to -2, -5. It's right there. And then our slope is -1, so I'm going to go down 1 over 1 in both directions. Okay? Down 1 over 1, both directions. Just like, oops, that. Okay? And then we put our lines like that, and we have our function. Remember that there are arrows on each end of these rays because they do go on to infinity in both directions there. Okay, so let's try the last one. Go ahead and find all those key pieces of information. So our vertex, we're going to start inside. I have the -2 and the +4. Remember that inside here kind of lies to you. This is actually going to be a +2, and then outside will be a +4. So that's our vertex. And then remember our slope is out in front. So this time our slope is a -1/2. Whoa, I don't know what just happened. And because that's negative, our orientation is that it's going to open down. Okay, so let's go put that on the graph. Our vertex is +2, +4, so that would be about here. Okay, so we make our point there, and then our slope is -1/2 in both directions. So that means we're going to go down 1 over 2 in both directions. So I have my dots, and now let's put our lines. And there you have it. And so that's how we graph absolute value functions. Go ahead and try your practice.